Alright, we should be recording, and now we are going to demonstrate the console edition of the calculator. Um, I should have mentioned in the previous video that, and Dr. Garrett, you'll remember that you and I had discussed the riddle of the broken calculator, as it were, and so the console calculator itself will follow PEMDAS because there's no clear function and therefore no real way to subsequently enter equations without significant strain. Now, I've already begun going through this. As you can see, the result of period is 0, the result of 0.1 is 0.1, the result of 1 is 1, and while I'm going along here, you'll notice that in between each equation it asks us if we'd like to continue. If not, it'll break the loop and we'll move out of the program, but in the meantime, this is where we're at. So now we'll start doing some arithmetic, and I will point out that in between each equation we get this Nash-Horn warning. I did do a little bit of research, and from what I read, this was planned to be removed, but then was not removed, and that was with respect to JDK 8, which of course is what I'm using because I have easier access to JavaFX with it. I haven't tried it, but my understanding is that I wouldn't be getting this warning if I was using a more current JDK, perhaps. Perhaps you could shed some light on that at some point. But in the meantime, I'm just going to continue to cruise along here. Oh, okay. Well, let's do that again. Obviously, my loop break only reacts to a no. So 0.55055, and then of course 10.5 minus 5. Oh my goodness, I did it again. There we go. This is 0.5. Of course, I can put in 10.5 minus 5 minus 5, and it'll give us the 0.5 expected. Moving right along here, minus 2 is minus 2, minus 2.2 plus 1 should give us, oh my goodness, I keep doing that, should give us negative 1.2, and then of course if I go slash enter, gives us 0, and multiply gives us 0, plus gives us 0, and minus by itself gives us 0. On to some actual deeper arithmetic. Of course, we have 1 plus 1 plus 1 will give us 3. And we'll move on to the next page where we get into the deep stuff. 5 times 5 is 25. And 5 times 5 times 5 is, oh my goodness, 125. 5 times minus 5. Now this is going to give us negative 25 because, again, it follows the rules of PEMDAS as it stands right now. If I go negative 5 times 5, and it's negative 25, of course, as well. And of course, if I go negative 5, gives me 10. Just to demonstrate it, can't of course get to that. 2 divided by 2 is 1. point divided by 2 equals 1. My equation. Oh, 2.5 divided by 0.5 should give us 5. That's the expected result. And of course 1 divided by 0. Oh my goodness. 1 divided by 0 gives us error. Now again, I think that should say undefined, although I did misspeak in my last video and said that my instructions said to make it 0. My instructions say to make it respond with error. I apologize for that. 8 divided by 2 gives us 4, and of course 8 divided by 2 divided by 2 divided by 2. Oh, I think I needed to have one more divided by 2 there. That'll give us 0.5. As expected, it can take as many operands as it needs, of course. Divided by 3. And of course, with 4 decimal places as requested, 2 divided by 3. 2 divided by 3. Again with 4 decimal places. 1 plus 1 plus 1 equals 3. Of course, 5 plus 6 divided by 2. 5 plus 6 divided by 2 yields 8 in this case, because it's following PEMDAS. But if we wanted to change that, of course, we can do so really, really easily by putting the equation in parentheses, because it will process that as well. And it gives us the 5.5 expected.